In this video, we are going to be doing a couple more examples from section 8.3. We're going to be looking at our second learning objective, which is finding the minimum and maximum values of a quadratic. So you are on the bottom of page 3 here with a few reminders that when our graph is downward facing, our vertex is a maximum because it's the highest point on the parabola. Think of it like the top of the roller coaster hill. And when our vertex is upward facing, and remember, upward facing means A is positive, and downward facing means A is negative. When we're upward facing, our vertex is at the bottom of the roller coaster, so then our vertex is a minimum. And so we want to find the value of the minimum. So that's going to be the y value or the value of the maximum, and that's going to also be a y value. Remember, top and bottom, height always comes from y values. So that's at our vertex. So finding the minimum maximum value is just finding the y portion of your vertex. That's what this says right here. The steps are find the vertex and find the y coordinate of the vertex. That's going to be your minimum and maximum value. So turn the page, let's look at our first example. So it says tell whether the function has a minimum or maximum value and then find the value. We can answer the first question right now because A is, I'm going to write them down, A is 8, B is 16, C is -2. If A is positive 8, ooh, I got a glare going on there. If A is positive 8, A is positive, means my graph is upward facing. My vertex is at the bottom of my graph, so my graph is a minimum. What is the value of my minimum? Well, I need to find the vertex for that. Finding the vertex, we're going to use that same formula we used in the first video, x equals -b over 2a. So x equals negative, remember I like to stick that negative up on the b. So negative in this problem, b is 16, so -16. Trying to see if I can get rid of that glare for you guys. Oh, there we go, that's a little better. Over 2 times a, 2, a is 8. Simplify that, -16, 8 times 2 is 16, I get -1. Holy smokes, I see a pattern. We keep getting x is -1. So remember, that's half of our vertex. So I'm just going to write vertex over here. I've just found half of it. To find the other half, I need to use my equation, which is y equals all of this. So if I know the x's, I can find the y. So y equals 8x squared plus 16x minus 2. What I want to do is substitute x equals -1 into my equation. So we're going to have y equals 8 parenthesis -1 squared plus 16 parenthesis -1 minus 2. Again, if you're using your parentheses, got a real glare problem happening here. There we go. If you're using your parentheses, punch that entire line in your calculator, and what you will get is -10. So my vertex is -10. So my max, or in this case, min value is -10. So I have a minimum value, and it's at -10. That's it really for this example. That one is a your turn. So pause the video and try that one. For this one, I'm assuming you pause the video. You have a maximum because your graph is downward facing, and you should have gotten it at -3. The setup for your vertex should have looked like this. So maybe if you made a mistake with your negatives, you can find it now. Your vertex that you should have found was -2, -3. Okay, we're going to look at a word problem in this video also. So it says the function here represents the height in feet of a rocket t seconds after it is launched. Remember, time is always your independent variable, so time is your x. In this case, how high the rocket goes is your y. So we got a rocket, I don't know, I'm assuming it's starting from the ground. It goes up, comes down. It's going to look like a parabola. Okay, so when does the rocket explode? And it says hint, find t, remind yourself that t is the same as x, when the rocket is at its highest point. Well, there's its rocket at its highest point. What do we call that? We call that the vertex. So they are asking you to find the vertex. All right, so this is the process we need to go through to find the vertex. We need to use x equals -b over 2a. So let's find our a, b, and c. I'm going to write them up here. A equals -4, coefficient of my t squared. B equals 24. C equals 9. So -b over 2a is going to be -24 over 2 times -4. So that's -4 over -8, which is +3. That's half of my vertex, remember? So I'm going to say my vertex is 3, something. To find what y equals when time, or x, is 3, I'm going to substitute 3 into my original equation. So y is going to equal -4, 3 parentheses squared, plus 24 times 3 plus 9. And again, put that whole line in your calculator. Make sure you're using the parentheses. -4 parentheses 3 squared. Don't forget the squared. That's a common mistake. Plus 24 parentheses 3 plus 9. And I get 45. So y equals 45. Okay, so I got 45 for my vertex. Now, remember, this didn't ask me for the whole vertex. It says, when does the rocket explode? When is asking for a time. Time is x. So when it explodes is 3 seconds. Oops. seconds. Remember, you got to have units. Story problem requires a story answer, which means units or words. So when does it explode? 3 seconds after it goes up in the air. Then it says, at what height does the rocket explode? So this asked for when, which is x. This is asking for what height, which is y. Well, we've already done all the work. It explodes right here at the vertex. That's at time is 3 seconds and height is 45 feet. All right, it's a couple more examples here, but I'm not actually sure if those are part of 8.3 or 8.4, so we are not going to put those in this video quite yet.